Let's solve this challenging trigonometric integral problem. We need to evaluate the integral of cosine x times cosine 2x times cosine 5x dx. We'll solve the step by step using the product to sum identities. First, recall that the product of two cosines can be written as 1/2 times the cosine of their sum plus the cosine of their difference. Let's first apply this to cosine x times cosine 2x. This gives us 1/2 times the cosine of 3x plus cosine negative x, which simplifies to 1/2 times cosine 3x plus cosine x. Our integral now becomes 1/2 times the integral of cosine 3x plus cosine x, all times cosine 5x dx. Now we can split this into two integrals and apply our product to sum identity again. For cosine 3x times cosine 5x, we get cosine 8x plus cosine 2x. And for cosine x times cosine 5x, we get cosine 6x plus cosine 4x. Combining everything, our integral becomes 1/4 times the integral of cosine 8x plus cosine 2x plus cosine 6x plus cosine 4x dx. Now we can integrate each term. Remember that the integral of cosine nx is sine nx over n plus a constant. After integrating and combining like terms, we get 1/32 sine 8x plus 1/8 sine 2x plus 1/24 sine 6x plus 1/16 sine 4x plus a constant. Comparing this with the given form, we can see that it equals 8, b equals 16, c equals 24, and d equals 32. Notice that these values form an arithmetic sequence with a common difference of 8. Therefore, a, b, c, and d form an arithmetic progression with first term 8 and common difference 8.